The ILS Proton mission for the SATMEX-8 satellite will entail 5 Breeze M burns and take 9 hours and 13 minutes from liftoff to injection into geostationary transfer orbit. Let's take a look at the SATMEX-8 mission profile.
The following is the description of the geostationary transfer orbit mission flight profile of the ILS Proton launch vehicle with the SATMEX-8 communications satellite on board. The first 3 stages function to propel the orbital unit to a suborbital trajectory. The orbital unit consists of the Breeze M, payload adapter system, and the SATMEX-8 satellite. The sequence starts with the ignition of the powerful first stage engines that output 2.4 million pounds of thrust at sea level. As the ILS Proton lifts off from its launch pad, it immediately executes a roll maneuver to align its flight launch azimuth to 62.3 degrees in order to achieve a parking orbit inclination of 51.5 degrees as it travels eastward. The engines fire for about 2 minutes, during which time the ILS Proton experiences maximum dynamic pressure. Then the first stage separation occurs. The second stage engines follow with nearly 540,000 pounds of thrust for 3.5 minutes. And then the third stage engine fires with 131,000 pounds of thrust for 4 minutes. The payload fairing is separated soon after third stage ignition high above the Earth's dense atmosphere. At stage 3 separation, the orbital unit has traveled from Baikonur to Russia near the eastern edge of Kazakhstan at 51.5 degrees north latitude and is moving about 7,300 meters per second or 4.5 miles per second relative velocity. The upper stage of the ILS Proton rocket is called the Breeze M and is designed to inject payloads into a wide variety of target orbits. There are 5 Breeze M burns in this GTO mission design. The first Breeze M burn occurs about 2 minutes after the third stage separation, when the orbital unit is still in a suborbital trajectory. This burn will create a low Earth circular parking orbit with an altitude of 173 kilometers above the Earth. This 4.5-minute burn spans from Siberia to Russia's east coast. A half revolution later, the second Breeze M burn occurs to create the intermediate orbit. This burn centers the ascending node of the parking orbit, creating the first elliptical orbit and establishing the perigee location to be on the equatorial plane. This 17.8-minute burn spans from South Atlantic, 800 miles east of Rio de Janeiro, to northern Libya. 1 revolution later, the third and fourth Breeze M burns occur to create the transfer orbit. These 2 burns, separated by the jettisoning of the auxiliary propellant tank, greatly increase the apogee to closely match the geosynchronous altitude, making the orbit more elliptical and maintaining the equatorial plane perigee location. Both burns add up to 17.5 minutes and span from South Pacific, 200 miles west of Santiago, Chile, to 300 miles west of Morocco. During the coast phases, the Breeze M performs attitude maneuvers in order for SATMEX-8's solar arrays to be exposed to the sun at a predetermined solar illumination angle, which is designed to satisfy its thermal and power requirements. During the 5th and final Breeze M burn, the orbital unit will perform a large plane change maneuver at apogee in the descending node from 49 degrees to 18.4 degrees inclination, and will increase its perigee altitude to about 6,200 kilometers, maintaining the line of apsides on the equatorial plane in a 7.5-minute burn. About 13.9 minutes later, the SATMEX-8 satellite is separated from the Breeze M to reach its targeted geostationary transfer orbit. The total mission time from launch to SATMEX-8 spacecraft separation is approximately 9 hours and 13 minutes, and the total travel distance is approximately 4 times the circumference of the Earth.
Once SATMEX-8 completes its in-orbit testing, it will provide fixed satellite services in North, Central and South America at 116.8 degrees west longitude.
The first burn of the Breeze M upper stage is scheduled for completion about 16 minutes into the flight. Our broadcast will conclude after that burn, since the rocket will be out of range of our tracking stations as planned, and we will not receive any updates at that time. You can stay up to date on the SATMEX-8 mission by visiting the ILS website, ilslaunch.com, by following us on Twitter, and by liking us on Facebook. Here's a message from Juan Garcia Gayu, CFO of SATMEX, recorded earlier in Baikonur.
Hello, I'm very excited to be here today. We're connected with the rest of the SATMEX team, not just literally but emotionally. This is a very important event for us. Almost 2 years ago, SATMEX was set in a path for growth, and with a little luck today, we'll see our plans for the future be enhanced. So I'd like to say thank you to everyone who made this possible. And Hermosillo y Iztapalapa reciban un afectuoso saludo, un afectuoso abrazo de todos los que estamos aquí. Y arriba SATMEX.
Khrunichev State Research and Production Space Center is one of the cornerstones of the global space industry and is the majority shareholder in ILS. With more than 45,000 employees, Khrunichev's varied product lines serve the global satellite industry as well as Russian federal and international space programs. Here's a little more now on Khrunichev.
Khrunichev State Research and Production Space Center has long been one of the most prominent space industry manufacturers in the world. Today, Khrunichev serves international satellite and space programs as well as Russian federal missions, working with 45 different companies in 22 countries across the globe. Khrunichev's diverse product lines include launch vehicles and launch vehicle upper stages, communication and Earth observation satellites, rocket engines, and space station modules. In 1993, Khrunichev joined forces with Lockheed Corporation and Energia in a joint venture to market Proton to the commercial satellite industry. In May of 2008, Khrunichev became the majority owner of that company, International Launch Services, or ILS. The merging of an American-based company with a Russian space industry giant was an historic first. The strategic consolidation that brought ILS into the Khrunichev fold also included bringing some of the largest Russian space manufacturers under the Khrunichev umbrella. The supply chain consolidation directly supports Khrunichev's most vital strategic asset, the Proton launch vehicle, as well as continued development of the next generation launch vehicle. Khrunichev's commitment to quality is exemplified in the phased improvements to the Proton launch vehicle. All upgrades have been 100% successful in flight. The phased improvements have increased Proton's lift capability to over 6 metric tons. And in 2011, ILS Proton launched its heaviest satellite, Viasat-1. The next phased upgrade will bring the total payload system's mass capability to 6.35 metric tons. And in direct response to operators' demand for lower costs to orbit for small to medium satellite launches, ILS and Khrunichev brought the ILS Proton Duo to the market. Using the full performance of the Proton rocket could reduce orbit raising time from 6 months to 4 weeks for satellites with electric propulsion. Khrunichev has also invested in infrastructure upgrades, including a second spacecraft processing facility in Baikonur, in full use since 2011. Refurbishments to Launch Pad 39 are now complete, following the upgrades to Pad 24 last year. Khrunichev's commitment includes the development of the next generation of launch vehicles. The Angara launch vehicle system will include a light, medium, and heavy lift variant to cover the entire satellite mass spectrum. The Angara engines will utilize an environmentally friendly liquid oxygen kerosene mixture. Ongoing investment and improvements, our unified quality management system, and our commitment to mission success allows Khrushchev and ILS to provide significant value to customers, and a steady launch tempo provides a backdrop for a sustainable future, serving the global space industry.
We are now under 6 minutes to launch. Now, also recorded earlier in Baikonur, here is SSL Senior Executive Director David Bernstein.
Greetings from Baikonur. I'm excited to be here on the eve of the launch of SATMEX-8. This is an important launch for us. This is our second satellite that we've built for SATMEX, and it'll be our 25th launch on the Proton. I'm also personally excited to be here since I've spent my entire career in the satellite business, and this will be the first launch that I'll actually get to see in person. I want to thank everybody who's been involved in the program. I want to thank our customer, SATMEX, who's been wonderful to work with over the last couple of years. And I want to thank the team from SSL, who's done a terrific job on designing and building this satellite over the last couple of years. I've checked with the team. We're all ready to go. So go Proton, go SATMEX-8.
And now here's a short video about SATMEX-8 prepared by SATMEX-8 manufacturer SSL.
Space Systems Loral, the leading manufacturer of high-power commercial satellites, designed and built the SATMEX-8 spacecraft for SATMEX. The satellite is designed to provide fixed satellite services in North, South, and Central America, including the Caribbean. Its advanced antenna design and overlapping coverage areas will provide video content and distribution, broadband services, and cellular backhaul in the Americas. To help people in remote areas, SATMEX-8 will also provide service for distance learning, telemedicine, and emergency services. The satellite will be located at 116.8 degrees west longitude, where it will provide service for 15 years or longer. SATMEX-8 will replace SATMEX-5, and together with Space Systems Loral-built SATMEX-6, it will serve as a workhorse to sustain the SATMEX business plan for many years to come. Throughout the SATMEX-8 program, the SSL and SATMEX teams worked closely together. The SSL team was led by Executive Director Rob Turner, and the SATMEX team was led by Program Manager Jesus Gutierrez.
SATMEX-8 is the second spacecraft that Space Systems Loral has built for SATMEX. The first spacecraft that we built was SATMEX-6, which was launched in 2006. It was part of the early new generation Omega spacecraft that we were building at that time. The on-site representatives from SATMEX, as well as their consultants, worked with us on a daily basis to ensure the success of this program.
We're happy to work with Space Systems Loral because together with the SATMEX team and our technical consultants, SAI, we work together and we address all the challenges that we encounter over the program. I believe teamwork and relationship was very beneficial to the program because it helped us to finish a quality product, which has become a very important asset for SATMEX. SATMEX-8 also means growth for the company.
SSL also provided ground control equipment improvements for SATMEX, including full upgrades in Iztapalapa and Hermosillo, Mexico.
I'd like to take this time to say thank you to all the people at Space Systems Loral that have dedicated their time to this program. Without your support, without your dedication, we couldn't have done it. Thank you.
Let's leave the last word before countdown to SATMEX CEO Patricio Northland, recorded just a little while ago in Baikonur.
Greetings to all. I'm here in Baikonur with our SATMEX team. We're very excited to be here. This is our first launch here from ILS Proton. We're excited to and looking forward to have SATMEX-8 in operation soon in a few days. SATMEX-8 represents our significant milestone of growth for our company, and we are very excited to be here. I wanted to thank you, the people from Loral and ILS, and especially our team from Mexico that has spent several days here. And again, we feel that this is a very important moment for our company. Go Proton, go SATMEX-8. Thank you.
And now my co-host Kieran Young will take us through the final pre-launch preparations and through liftoff of SATMEX-8. Kieran?
In addition to those at the launch site, there are many others watching who have played an important role in the SATMEX-8 mission. And we'd like to say gracias for all your hard work in getting to this moment. SATMEX in Mexico City, Mexico, SSL in Palo Alto, California, Khrushchev in Moscow, ILS headquarters in Reston, Virginia, and many others who have helped make today's launch of SATMEX-8 a reality. We are about 15 seconds to launch. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition start. We have liftoff of an ILS Proton rocket from the Baikonur Cosmodrome in Kazakhstan with the SATMEX-8 satellite on board. It can be a little difficult to see, but at about 10 seconds after liftoff, the rocket does a roll maneuver and will soon experience maximum dynamic pressure, also known as max-Q, and is the maximum aerodynamic load on the vehicle. For Proton, it corresponds to about Mach 1.6 and occurs at 1 minute 2 seconds after liftoff. Everything seems to be proceeding nominally as the vehicle heads across the Cosmodrome vertically in a northern-easterly direction with a flight launch azimuth of approximately 6.13 degrees. So as we can see, it's a beautiful night out in Baikonur. We have clear skies and we can watch this rocket on its flight path.
You know, as the ILS Proton travels easterly downrange, our viewers are going to notice some time lags in our reporting of key mission milestones. Now, the reason behind this delay is that as ILS Proton follows its pre-programmed flight path, it will pass out of range of the Baikonur receiving stations. Now, at this point, signals are received by stations downrange and transmitted back to Baikonur, so this does cause brief delays in our reporting.
We are coming up on the first stage's separation from the second stage. That is set to occur at 2 minutes into the flight. Zach, have we got confirmation? And we have confirmation of a good separation between the first and second stages. Okay, we're all proceeding as nominal and as planned. We have a signal of ignition on all 4 second stage engines. They will burn for a total of about 3 minutes and 27 seconds. The next key mission milestone will be stage 2-3 separation at L plus 5 minutes and 27 seconds. 20 seconds after that, the payload fairing pyros will fire, separating the 2 halves, and they will be jettisoned from the vehicle.
Now let's take a chronological look at SATMEX-8's journey to launch.
Typically, it takes about 2 years for the launch vehicle and satellite to be built, tested, and shipped to the launch site. From crew and spacecraft arrival, it can take from 4 to 7 weeks to complete a launch campaign. Today's launch begins with the early team arrival in Baikonur. The spacecraft arrives aboard an Antonov cargo jet at Yubileyny Airfield. The spacecraft is offloaded from the plane and placed onto a railroad car. The thermally controlled railcar is hooked up to maintain the proper environmental conditions for the spacecraft during the 6-hour trip to the launch processing facilities. Once in the high bay, the spacecraft team does a series of system tests and other standalone operations, including fueling the spacecraft. Fueling of the spacecraft is then completed. The satellite is then mated to the Breeze M upper stage and rotated horizontally to be encapsulated in the payload fairing in Hall 101. The spacecraft, fairing and upper stage are now referred to as the Ascent Unit. The entire assembly is mated to the booster stages of the ILS Proton launch vehicle in Hall 111. The integrated launch vehicle is rolled to the Breeze M fueling station, where fueling of the Breeze M is completed. The complete rocket rolls out to the launch pad, where the entire vehicle is changed from its horizontal position on the railcar to a vertical position on the launch pad. Then the service tower is moved into position. The mobile service tower provides services and accessibility to the launch vehicle and spacecraft. Proton rollout to the pad always occurs at exactly 6:30 in the morning, corresponding with the precise time the vehicle for Yuri Gagarin rolled out in 1961, marking this landmark anniversary in space advancement.
The Proton rocket is able to lift very heavy payloads into orbit. Proton launched Russian interplanetary missions to the Moon, Venus, Mars, and Halley's Comet. Proton also launched the Salyut space stations, the Mir core segment, and both the Zarya, meaning dawn, and Zvezda, meaning star, modules for today's International Space Station. Proton is a powerful rocket with the first stage engines producing 2.4 million pounds of thrust at sea level. Let's take a moment to learn more about the development of Proton. The Proton launch vehicle is the backbone of the Russian space industry with a long and significant history. Here are some quick facts. The Proton is the largest and most powerful Russian launch vehicle in operation. It has been launched more than 350 times since the mid-1960s. Khrushchev Research and Production Space Center, the majority owner of ILS, is one of the pillars of the Russian aerospace industry and manufactures both the Proton rocket and the Breeze M upper stage. While the first Proton mission was in July of 1965, the first commercial Proton launch took place almost 30 years later in April of 1996. The UR-500 vehicle's first 3 payloads were spacecraft called Proton 1, 2, and 3, and subsequently, the launcher was named after its original payload. Khrushchev manages federal launch missions while ILS offers the Proton for commercial satellite launches. There are about 7 to 8 commercial missions a year and 3 to 5 federal missions, launching at a rate of about 1 per month. We are now just over 7 minutes into flight and coming up on some important milestones. Kieran, what can you confirm for us?
I confirm that we have second, third stage separation and payload fairing due to